Hello, my name is Aaron Justice, and my presentation is over the analysis of vegetation on the Catalina Mountains from 2000 to 2020. The what and the why. What is this project? So this project is an analysis of vegetation difference in the Santa Catalina Mountains, more specifically the northeast section of the Santa Catalina Mountains, and it spans a total of 20 years from 2000 to 2020. The why. So part of the reason why I had an interest in this study is because I currently live in Tucson and was present during the 2020 Bighorn wildfire. The thing that piqued my interest to get this project started was when we were looking at the national land cover data difference from 2000 to 2020, with there being a fairly noticeable change in the vegetation, more specifically the forested areas up in the mountain. So a little bit of background on the Santa Catalina Mountains. They're located east to northeast of Tucson. They are considered a sky island, which is an isolated mountain range that is surrounded by desert. The elevation range of the Santa Catalina Mountains ranges from the lowest valley being 2,850 feet to the highest peak being 9,150 feet. The highest point atop the Santa Catalina Mountains is Mount Lemmon. This highest point is also home to the Mount Lemmon Ski Valley, with the town of Summerhaven being just beneath that. The Santa Catalina mountain range is the most recreationally active among all of the mountain ranges surrounding Tucson, with numerous hiking trails as well as a 25-mile paved road with plenty of parking pullouts to stop and take in the scenery. The focus area for this study is the part of the Santa Catalina Mountains to the northeast of Tucson, containing Push Ridge Wilderness area, as this is the area that has been impacted by fires during the time frame of this study. This area also happens to contain Mount Lemmon as well as Summerhaven. So a little bit about the wildfires that have affected the Santa Catalina Mountains. During this time frame from 2000 to 2020, there were 3 notable fires. The first being the Bullock Fire that happened in 2002, spanning from May 12th to June 10th. The area burned for this fire was 30,563 acres. The next is the Aspen Fire that happened in 2003 and spanned from June 17th to July 15th, burning 83,753 acres and damaging 330 structures and causing a significant amount of damage to Summerhaven. And the last fire is the Bighorn Fire that happened in 2020 and spanned from June 5th to July 23rd, and burning almost 120,000 acres. This fire was caused by a lightning strike, and while it avoided damaging most human property, unlike the Aspen Fire, it did cause a significant amount of damage to the wildlife habitats of the Push Ridge Wilderness area. For this study, I focused mainly on the 2 largest fires, the Aspen Fire and the Bighorn Fire, as they overlapped and covered the most area for where the change was occurring in the land cover. In the graphic included on this page, there is the Aspen Fire outlined in blue and the Bighorn Fire outlined in gray. These images were taken by the Tucson National Weather Service, with the upper left picture being of the Aspen Fire and the lower right picture being of the Bighorn Fire. So a little bit of rainfall information for the dates of the Aspen and Bighorn fires. So the average rainfall for Tucson, Arizona in June is 0.28 inches, and it is considered the second driest month of the year, with the average rainfall for Tucson in July being 1.93 inches, and considered the second wettest month of the year on average. In 2003, the rainfall total for June was 0 inches, meaning there was no rain. The July rainfall totals for Tucson in 2003 were 2.26 inches, which was higher than the average for June. In 2020, the June rainfall total for Tucson was 0.05 inches, meaning there was barely any rain, with the July rainfall total for Tucson being 0.46 inches, which is way below the July average. The 2020 monsoon season was the driest monsoon season on record, with a total of 1.5 inches of rainfall during the monsoon season, following 2019's dry monsoon season, causing vegetation to be dry and highly flammable. What is a monsoon and why does it matter? Monsoon is a large-scale shift in the weather pattern that pulls moisture in from the Gulf, bringing moist tropical air to the desert. Typically, the monsoon season runs from June 15th to September 30th, but when the monsoon season starts and ends significantly depends on weather patterns and a setup that has happened previously in the spring before the start of monsoon season. With a lack of moisture and thunderstorms, with a lack of moisture and the start of thunderstorms in the beginning of June, the threat of wildfires started by lightning significantly increases at the beginning of the season. And once there is an increase in rainfall and moisture, the threat of wildfires drastically decreases in the months that follow due to the amount of moisture and the fact that the vegetation is now getting the rain that it needs. So for the methods of my study, I started out by looking at the National Land Cover data layer for 2000 and 2020, and I noticed an obvious difference in the amount of forest left on the mountain in the 2020 land cover. I also decided to look up the FEMA wildfire frequency census map, and while the numbers show the annualized frequency for the entire United States, I used this layer more as a means of showing where the Santa Catalina Mountains fall in terms of probability of having a wildfire, which to me shows a moderate risk. After looking at the land cover data, there were 2 satellite images that were downloaded. Landsat 7 was downloaded from 2000 and Landsat 8 for 2020. And the images were used to identify the difference in land cover more vividly, showing an even more drastic change in the amount of vegetation from 2000 to 2020. After these Landsat images were downloaded, they were then classified into 5 categories, showing the decrease in forest cover on the Santa Catalina Mountains even more in depth. From there, vegetation health was measured using the NDVI tool. And then the Landsat 7 and the Landsat 8 image were compared. The image at the top with the red area shows the vegetation change from 2000 to 2020. And if you reference the images on the bottom of the infographic, it shows that most of this change was a decrease in vegetation over the 20-year time span of this study. In conclusion, wildfires and drought seem to be the main cause of the damage to vegetation and the decrease in vegetation on the Santa Catalina Mountains. It is very jarring to see such a drastic difference in land cover over the span of 20 years. And drought and wildfires can cause serious damage to wildlife habitat, ecosystems, and human health. Not only do these fires cause damage to humans secondhand when they're happening in the form of air pollution, damage to property, and possible loss of life and resources, there is also a lasting effect on the environment. Plant life that regrows can change, and the wildlife habitat and species are long-term affected. Some of the future research possibilities for the Santa Catalina Mountains and the wildfires that occurred are looking at rainfall data more in depth to see how it affects wildfire patterns in the mountain range, looking year to year to see what those rainfall rainfall totals were, and how prone the mountain was to starting any sort of wildfires in those years where there was less rainfall. Another possibility could be mapping drought patterns, and this ties hand in hand with the rainfall data to see how it affects the plant life on the mountain. Another possibility would be looking at monsoonal patterns and statistics of lightning strike probability in correlation to wildfires on the mountain. And another one could be year-to-year analysis of new growth and change in vegetation pattern and type over time after these wildfires occurred. This concludes my presentation. I hope you guys enjoyed it. Thank you very much.